Alright, it looks like the previous video got cut right when I was writing the final answer to this. So let me recap what we were doing before. So what I did is to put this exponential factor together with the 2x, and at the same time I just reversed the order to write the positive quantity first and then the negative quantity. Alright, so that was the final answer for exercise letter D. For letter E, notice in this case, what do we have? So ln of e to the x, ln of x, where in this case, well, do you really want to do 1 over e to the x, ln x, times the derivative of e to the x, ln x, using another product rule, and then, well, I mean, although it's doable, but you don't need to do that. And that's because in this case, we can use properties of logarithms, that is, ln of ab equals ln of a plus ln of b. So in this case, let me rewrite the function ln of e to the x plus ln of x. Okay, so what are we going to obtain over here? So number one, this ln of e to the x, ln of e cancel each other. That's something that you may have reviewed in the videos from the previous module, in which we did the review of how do we work with exponential functions, logarithmic functions, how are they inverses of one another, and we also work with the properties and solve the equations. So in this case, we will reduce this into x plus ln of ln x. Alright, so let's take the derivative, y prime, the derivative of x is 1, the derivative of ln x, that's a 1 over ln x, times the derivative of ln x, which is x, and we already did this one before, the derivative of ln x, let's just combine it the following way, 1 plus x ln x in the denominator under 1. And we could leave it like this, that's fine. Okay. So let's look at letter F. So for letter F, we have this ugly looking exponential function for which we're going to use the quotient rule and also somehow mini chain rule. So in this case, okay, let's write the derivative of the quotient again. The quotient rule, u prime v minus v prime u over v squared. So in this case, y prime is the derivative of the numerator, which is the derivative of e to the 2x, which is itself e to the 2x times its derivative, which is 2, minus e to the negative 2x times its derivative, which is negative 2. So that quantity, that times the denominator e to the 2x plus e to the negative 2x, minus the derivative of the denominator, which is the derivative of this quantity right here, that is e to the 2x, which is itself, times the derivative of the exponent, which is 2, plus e to the negative 2x times negative 2, and then that times the derivative, actually just the numerator, e to the 2x minus e to the negative 2x, and then the whole thing divided by e to the 2x plus e to the negative 2x quantity squared. So let's simplify all this. So first of all, let me clean up some parentheses. Let me rewrite some coefficients in the front of the exponential. So that will be y prime equals to 2e to the 2x, and then minus times that minus, that's going to be a plus 2e to the negative 2x. That times e to the 2x plus e to the negative 2x minus, in this case, 2e to the 2x minus 2e to the negative 2x, and in this case that's because plus times a minus, it's going to be a minus, and that times e to the 2x minus e to the negative 2x. Alright, so yes, it looks like this one will require a little bit of foiling. So let's go ahead and do all this. Okay, so let's multiply these two. 2e to the 2x times e to the 2x. So, okay, let me do on one side what we are supposed to do. So, in some cases, we will multiply e to the 2x times e to the 2x. And in other cases, we will multiply e to the 2x times e to the negative 2x. All right, so let's see what do we do in each situation. So in this case, the base is the same. What we do is add the exponent. That's e to the 2x plus 2x, which is 4x. And in this case, e to the 2x minus e to the 2, times e to the negative 2x. That's basically saying, so what we're doing here, we're adding 2x plus 2x, and over here, e to the 0, because in this case, 2x minus 2x equals to 0, which equals to 1. All right, so in this case, so that's 2 e to the 2x times itself, that's e to the 4x, and then times 2 times 1, which is e to the 2x times e to the negative 2x, and then distribute these two, FOIL those two, that's 2 times also 1, because e to the negative 2x times e to the 2x, they cancel the 1, and then plus 2 e to the negative 4x, in this case negative 2x plus negative 2x, that's negative 4x. And then minus, I'm going to open parentheses to do the same foiling. Multiply, multiply. That's 2 e to the 2x, or no, not e to the 2x, rather e to the 4x. And then minus 2 times 1, and then minus 2 times 1, which is this. This distribution, and then minus minus, which is plus e to the negative 4x, and then let's divide the whole thing by e to the 2x plus e to the negative 2x quantity squared. So in this case, this is what's going to happen. Let's combine like terms. On the one hand, notice how 2e to the 4x cancels 2e to the 4x over here. The same way 2e to the negative 4x cancels 2e to the negative 4x over here. And we are going to be left over here with 2 times 1 plus 2 times 1, that's a 4. And that's over here a negative 4. So we will be left with, I know we had a lot of terms, but this one simplified really nicely. So that's a 4 minus a negative 4, the whole thing divided by e to the 2x plus e to the negative 2x quantity squared. And this becomes a 4 plus 4 e to the 2x plus e to the negative 2x quantity squared. And that's an 8 over e to the 2x plus e to the negative 2x quantity squared. And that's a final answer for this exercise. And so this is the end of this section 5.4, derivatives of exponential functions. So I will see you in the next video.